हाय फ्रेंड, आज आपण कायरलिटी ऑफ मॉलिक्युल्स विदाउट स्टेरिओजेनिक सेंटर्स that is absence of chiral center चे examples पाहणार आहोत. In this, the absence of chiral centers, chiral molecules like the carbon bonded four different groups compound, like suppose these are the molecules bonded with different groups like A, B, C and D. The such carbon is known as chiral carbon atoms or asymmetric carbon atoms. This molecule shows optical active compounds to optical active isomerisms due to there is a presence of chiral centers. Okay, chirality is essential for optical active component. In here, the carbon bonded four different groups. The centered carbon atoms known as chiral carbon atoms, it also symmetric centers, or it also known as stereogenic carbon atoms. The such molecule shows optical active isomerisms due to presence of chiral centers. But in some cases, like there is absence of chiral centers, but they shows optical active molecules like the compound like allenes, then second one biphenyls, and then third one spirans. Allenes like cumulated system, carbon carbon continue double bonded molecules. Biphenyls molecule like two benzene nucleus joined together by one single bonds, and spirin molecules the two cyclic component having one common carbon atoms, like these are the Spiro systems. The such molecule shows optically active molecules or optically active compounds. That means it gives isomeric pairs. The allene, biphenyls and spirans, they do not have asymmetric carbon atoms or chiral carbon atoms like these molecules. These molecules contain chiral carbon atoms, and this shows optical active compounds. But the molecule like allene, biphenyl and spirin compound, they do not contain any chiral centers or stereogenic centers or chiral carbon atoms, but it shows optical isomerisms due to presence of molecular chirality. That is, it gives non-superimposable mirror image compound. Non-superimposable mirror image compound. Therefore, the such molecules are called as optical active molecules, but absence of chiral centers. Now, the first example, that is allen system, it also known as the stereochemistry of cumulene system. The cumulene means that is the compound having two or more than two cumulative double bonds are called as cumulene compounds. Like the compound contain carbon carbon double bond. These again carbon carbon continuous double bonded systems are known as cumulative compounds. It contain two or more than two cumulative double bonds. Cumulative double bonds. The compound having odd number of dB, it gives geometrical isomerism. It gives geometrical isomerisms, or the compound contain even number of, it gives optical isomerism. Now the example of cumulene systems, the compound like CH3, CH, double bond C, double bond C, double bond C, H, CH3. Now in these molecules there are three continuous double bonded system like 1, 2 and 3. That is the odd numbers of double bond, therefore the such molecule gives geometrical isomerisms, like it gives geometrical isomerisms, geometrical isomer, that is compound shows geometrical isomerisms due to presence of odd numbers of double bonds. And the molecule like phenyl group, then carbon double bond H, C, double bond C, double bond C, pH, H. In this molecule there are even numbers of double bond, that is there are two continuous double bonds, therefore this molecule gives optical isomer. It gives optical isomerisms, optical isomers. In cumulene systems, there is continuous double bonded molecules like the compound containing odd number of double bonds or even number of double bonds. The such molecule gives the compound contain odd numbers of double bonds like carbon carbon double bond, this double bond, this double bond. That means these are the three double bonded system molecules. It gives geometrical isomerisms. And the another examples, these molecule contain there are even numbers of double bonded system, that means it contains two double bonds, therefore it gives optical active isomerisms, or optical isomerisms are possible for these molecules. Now how it is possible, that is if the molecule contain odd numbers of double bond, then it gives geometrical isomerisms, and if molecule contain even numbers of double bond, it gives optical isomerism. Now we can understand by using the one another examples. The carbon are always adapting TD structures like these are the carbon molecules, normal carbon atoms adapting the tetrahedral structures. In the tetrahedral structures, the continuous lines indicate, suppose these are the groups A, B, C and D. The central carbon atom adapted TD structures, the continuous lines indicate on the plane groups, and the wedge line and dotted line indicate out of plane groups. Now these are the four bonded groups carbon atoms, that is TD structures. These are the more stable geometry of these molecules. Therefore in the double bonded systems always try to adapt the more stable condition of carbon atoms. That means carbon always try to adapting TD structures. But in double bonded systems, the example like suppose the molecule contain three double bonds, continuous double bond, and then these odd numbers of double bond molecules, suppose these are the carbon atoms, and the four different group of carbon atoms like these are the wedge lines, out of plane groups, dotted lines, and the another two groups like continuous lines on the plane groups. These are the one carbon atoms. Okay, like these carbon atoms, if we are considering these groups CH3AH, then this molecule bonded with the second carbon atoms, again second carbon atom groups on the plane groups. These are the on the plane groups, and the another two groups of these carbon atoms like these are the on the plane group, therefore these are the out of plane groups. That is the carbon number second, carbon number third, again bonded with the new carbon atoms. This again the four group of carbon atoms. These are the out of plane groups. Now the remaining two groups, they are present on the plane groups like this. Okay, and then the third carbon atoms like this. These again on the plane groups, and the remaining two groups, they are present out of plane groups like EH and CH3. Now see the actual bonding nature of odd numbers of double bonded cumulene compounds. These are the first double bonded groups. These are the first double bond, second double bond, and these are the third one. That means this molecule contain total three cumulated double bonds, odd numbers of double bonds. Nature of terminal groups. These are the outer plane. These are the outer plane. That means these are the both outer plane group present on the same plane. Therefore, the such molecules it gives geometrical isomerisms like cis or trans compounds. Cis or trans molecules possible for the odd numbers of double bonded compounds. In second example, like these are the carbon atoms, the four bonded groups, like these are the outer plane groups. These are the outer plane groups. These two are the on the plane groups. Then again these are the outer plane groups. Okay, and these are the on the plane groups. Now in this molecule there are, these are the first double bond, these are the second double bond. There are two double bonds, continuous two double bonded system, that is cumulene system. In here it is even numbers of double bond. Therefore the terminal group of this molecule, they are present on the outer plane, on the plane groups. That is both terminal group, they are present on the different plane. Therefore the such molecule gives optical active isomerisms, and the odd numbers of double bonded molecules gives geometrical isomerisms. Non superimposable mirror image compounds, that is optical isomers for the even number of double bonds, and odd number of double bond it gives geometrical isomerisms. The example of optically active molecules like 4-phenyl butane 2,3 diunic acids, like the structure of molecules pH C H double bond C double bond C H pH. These are the example of optical active molecules. Optical active form